Welcome all. Today we will look into development of surfaces. Actually, development of surface or development of surfaces of solids is nothing but an object hollow and made up of thin sheet. That is the assumption. Cut open it from one side and unfold the sheet completely. Then the shape of that unfolded sheet is called development of lateral surfaces of that object or solid. Then the lateral surface is that surface which excluding solids top and base. And there are so many engineering applications for this the development. There are so many products or objects which are difficult to manufacture by conventional manufacturing process because of their shape and sizes. Those are fabricated in sheet metal industry by using development technique. There is a vast range of such objects. These are the engineering applications, and these are the examples: boiler shells and chimneys, pressure vessels, trays, boxes, feeding hoppers, large pipe sections, etc. are the examples for the usage of development of surfaces. Then, to learn the methods of development of surfaces of different solids and their sections and frustums. This is the main objects of this particular topic. Then, but before going ahead and note the following important points. These are the assumptions. First one, development is different drawing than projections. Most important one. It is a shape showing area. Means it's a 2D plane drawing. Actually, the surface means surface of a solid or lateral surface of a solid means it is a two-dimensional drawing. Actually, it is a two-dimensional drawing. There is only one plane figure. Hence, all dimensions of it must be true dimensions. That is the most important point in development of surfaces or in the development of the lateral surfaces. All the dimensions must be in true length. All the dimensions must be in true length. That is the most important point. And as it representing true shape of the unfolded sheet, no edges can be remain hidden, and hence dotted lines are never shown on development. All edges are visible in the case of development of surfaces. So visible edges must be in thick line, or otherwise we can draw thin continuous line. Never use dotted lines. First object, development of lateral surface of different solids. In that case, first object is a cylinder. Then we can see that we can exclude this top surface and bottom surface. Then the development of lateral surface, this curved surface must be a rectangle. Whenever we cut this lateral surface through this point or through this line, and we can unfold the entire lateral surface, then we will get a rectangle like this. And this entire length must be equal to the perimeter of this circle. That is equal to 2 pi r. Perimeter of the circle that is equal to 2 pi r. Then that length is equal to 2 pi r, or otherwise pi into d, where d is the diameter. Of the cylinder. diameter of the base circle of the cylinder. Then this must be the height. Then this total area is equal to pi into d into h, pi dh, pi dh. H is equal to height, d is equal to base diameter. Then next category, prism. Next category, prism. First category, cylinder, and the shape of the development of the lateral surface is equal to a rectangle. In the same model, the development of lateral surface of a prism must be another rectangle, but there is some changes are there because there are so many vertical edges. Then in the development of the lateral surface, we must represent that vertical edges by thick straight lines. Here in the case of cylinder, there is no particular vertical edges, so all the vertical lines are generators in the case of a cylinder, and all the generators have the same priority, so we can't represent a particular generator. For construction purpose, we can draw generators using thin continuous lines. In the case of prism, the lateral surface development is a rectangle. Then this length, the distance between two vertical edges, is equal to s. S is the length of the side of the base polygon. Then if it is a 5-sided polygon, then s must be repeated 5 times. Then only we will get the complete development of the lateral surface. Actually, this is a combination of n number of rectangles, where n is the number of sides of the regular polygon. Another one, cone. Actually, the development of cone is nothing but a sector of a circle. Like this. Here this included angle. This angle is equal to angle we can represent as theta, and this perimeter, and we can represent this length as L. L means the true length of the generator. If this particular generator shows true length in front of you, we can treat it as L. Then this is a true length of the generator. We can treat it as capital R. Then this arc length is equal to R theta, otherwise L theta. Arc length is equal to R theta or L theta. Here we can use capital L instead of capital R. Then we can see that the radius of the base circle, we can use this radius of the base circle. Here they used radius of the base circle as capital R. Then we can use this as capital R. Otherwise, we can use this radius of the base circle as small letter r. Then this radius is equal to small letter r. Then this perimeter is equal to perimeter is equal to 2 pi r. Then we can equate that 2 pi r, this perimeter must be equal to this arc length. That 2 pi r is equal to capital R theta. Then we can say that this theta is equal to 2 pi into small r divided by capital R. If we use capital L instead of R, theta is equal to 2 pi small letter r divided by L. 2 pi small letter r divided by L. Then we can use capital R instead of small letter r. Then this equation will become like this. In this case, theta must be in radian. In this case, theta must be in radians. Then if we use the unit as degree, then we can say that theta is equal to, instead of 2 pi, we can use 360 degree into r small letter r by L. We can use this notation also. If we use capital R as base circle radius, this radius as capital R, then we will get theta as r by L into 360 degree. But we never use capital R as the length of the generator and the radius of the base circle simultaneously, because this radius is not same as this radius. We can use different notations, and this theta is equal to 360 degree into small letter r by L, where r, small letter r, is the radius of the base circle, and L, capital L, is the true length of the generator. We can use theta as capital R by L into 360 degree also, where capital R is the radius of the base circle, and L, capital L, is the true length of the generator or slant height. We can use any equation conveniently. Next, pyramid. Here, actually, the development of lateral surfaces is a combination of isosceles triangles. When this particular pyramid is right-angled pyramid, then the lateral surface must be the combination of isosceles triangles. Here we can see that this S is equal to the length of the one side of the base polygon. Length of the one side of the base polygon, and that is equal to S. And this L is equal to true length of the slant height. Here we can use the L as true length of the generator. Here this L is equal to true length of the slant height. And this is the development of the lateral surface of the pyramid. We can draw this figure by taking a convenient point as this apex. Then first we can draw the true length of the slant height. Then we can draw an arc. Then we can cut that arc by drawing another arc having length is equal to S. From this, by cutting another arc having radius is equal to S, and we can draw that arc like this. We can repeat that arc n times, where n is the number of sides of the base polygon. Then we can connect that points by straight lines. Then we can complete the development of the lateral surface. If it is a four-sided polygon, then we must repeat that procedure 4 times. That is the final answer. Then the development of the lateral surface of the tetrahedron. Tetrahedron means actually it is a combination of 4 equilateral triangles. Here we can draw the center triangle first, then we can draw other triangles like this. All sides must be equal. And that side length is equal to the true length of the base triangle of the tetrahedron. True length of the one side of the base triangle. Then the combination of 6 squares is the lateral surface development of the cube. In the case of cube, as in the case of this prism, we will get a combination of 4 squares. Then we can also add one square in top face and one square in the bottom face. This is the total development of this surface. Here this figure includes all the surfaces, not only the lateral surface but all the surface of the cube. Thank you all.